Hi, this is Bill Punch from Michigan State University. This is another video in the series of videos, The Practice of Computing Using Python, CSE 231. Today we're going to talk about dictionaries, a very useful data structure, one that we have found lots of uses for, and I hope you'll enjoy as well. Let's get started. So some of the features of dictionaries: it's a data structure that has a couple of particular features. It's also called a map or an associative array. For all intents and purposes, what a dictionary records is a set of key value pairs. The function of a dictionary is to look up keys and find the associated value. The analogy is, in fact, a book dictionary. If you're looking for a particular word, the key in this case, the dictionary is organized alphabetically to make that very easy to do. We can look the word up and find its associated value, the definition. A dictionary is a collection, but it's not a sequence. There's no order to a dictionary. There's no index number. There's no sequence number because there's no order to the elements in a dictionary. Dictionary orders change to maximize the efficiency in looking up a key. Dictionary is a mutable data structure, so we can change it in place. And like lists, a dictionary can have any sequence of items of any types except for one restriction. The key must be an immutable data type, a string, a tuple, an integer, a floating point value. Cannot be a list, cannot be a dictionary. So how do we designate key value pairs? Key value pairs are designated with the colon, and the value in front of the colon is the key. The value behind the colon is the value that's associated, and this is the association that gets stored in the dictionary. This key is associated with this value. Three ways to make a dictionary. The shortcut for dictionaries are braces, like they were square brackets for lists. Key value pairs stored in braces make a dictionary. There's also two other ways, which we'll look at in a second. Here's an example. Here's a dictionary. Here are the braces indicating that we're working with a dictionary. Here's a pair, a string with an integer. Here's a pair, a tuple with a list. Here's a pair, an integer with a floating point value. If we evaluate this, we get a dictionary, just as we said. The order might change, but that's the dictionary. There's a nice function called the zip function. The zip function makes tuples out of two lists. The way it does so is it takes the first element out of the first list, the first element out of the second list, and puts them together as a tuple. Then the second element with the second element, the third element with the third element makes a nice set of tuples. We can use the zip function to make a dictionary. The dictionary constructor requires a list of tuples. Zip it does exactly that, so we can take our name list and our grade list and put them together, make a dictionary of Bill, Fred, and Harry, 100, 200, 300. We can also use keyword arguments, and so for the dictionary constructor, I can say that I want the key to be Bill and its value to be 100, indicated by the assignment, Rich 200. And interestingly, when you print this out, you'll note that the key that's placed in is quoted. And so no quotes here for Bill, but it's a quoted string here. No quotes here for Rich, but a quoted string there. Even though dictionary is not a sequence, we can still use the square bracket operators with a dictionary with the following difference. What goes between the square brackets is not an index value, but a key. So we use the key inside of square brackets to access elements of a dictionary. The way it works is that for dictionary 2 up here, let's see right there, Bill 100, Harry 300, Fred 200. Right, if I say, so what value is associated with the key Bill? I put the key in the square brackets, and what gets brought back is the associated value. If I try to do that and it turns out that the key does not exist in that dictionary, then when I try to evaluate this expression, I get a key error. That is, I looked it up in the dictionary, there's no such key as Irving, it's not there. When I do creation of a key, I do it by assignment just like I would for a variable. And so dictionary 2 doesn't have an Irving. We just saw that we got that error. So we're going to say, look, I'm going to assign to the dictionary under the key Irving the value 500. The key doesn't exist. We'll create it now in the dictionary. If the key does exist, there is a Bill. We're going to update its value to 700, so we'll show the before and the after. So Bill was 100, now 700. Irving was not part of this list, now he is. Standard collection stuff that exists. We have length. That is the length of the number of key value pairs. Dictionaries are always key oriented, so I've asked the question, is Bill in the dictionary? I'm asking a Boolean about keys. Is the key in the dictionary? If I iterate through a dictionary, I by default am iterating through keys. So let's take a look at all of those. So what is the length of the dictionary? There's 4 elements in there now. Is Bill in the dictionary? It is. Those are the 4 keys then to go through. Some other methods. There's a dot items method that returns as a tuple the key value pairs. And so if I were to run this, interestingly, what you get back when you run one of these special methods is called a dictionary view. But that's a thing that you can iterate through, and so I can turn it into a list. If I want the keys, even though I don't necessarily have to do that, there are all the keys. If I just want the values, dot values, I can clear the dictionary. So it starts out with some values, I clear it, and there's nothing left. If I try to do it for dictionary 2, and I remove Irving, I can remove it with the del function. The del function removes a particular key from the existing dictionary. You can do multiple assignments, which is kind of interesting. If you remember this, here is a tuple that has the 2 values, 1 and 2, associated with it. If I do multiple assignment, the first element goes to the first, the second goes to the second. So if I run this, first and second pick up the values 1 and 2. I can do the same thing in dictionary items. Because dictionary items returns a tuple, I can grab the first element of the tuple as the first value, the second element of the value, the second one, and I can iterate through all the key value pairs and look at them.